Testing the microphone. Okay, here we go. In one of our last exciting episodes together, we were talking about structures. This will be a quick recap of some of the stuff we've done, except with a different perspective on it. So we're going to talk about structures, the dot operator, constructors, and structures as arguments, initializing structures, the idea of interfaces, implementing, and of course, where would this all be if we weren't economically viable? To be economically viable, of course, we need a client, we need some sort of problem to solve. There are many problems: aerospace problems, computer games, banking, robotics. This all involves keeping track of lots of variables and the names of the variables and what they're doing. Weather stations, robotic surgery, artificial intelligence, computational biology, the list goes on. We need tools, language tools. So we're extending our ability to construct in our programming language with C++, features to help us describe a problem. All right, that new tool is struct. It means to group things together, to glue variables into a single type, right? Some sort of aggregate. And it's custom design. We make it. And before you can use it, you have to define it. Not the end of the world. Here's an example of a structure. Well, first, it's usually globally defined. No memory is created. It's a blueprint. So if I say a certificate of deposit, a CD, is a double balance, double interest rate, terms of the loan, or of the investment in months. It's just a blueprint. Nothing is built. However, in code, if I say CD account, these three variables will be glued together, just like a home. To get inside, there'll be something we call the dot operator. The parts of it are called member variables or member fields. It can be very, very complex. Structures can have structures inside of it and functions. Here's an example. I have a box. The box has a product name. The box will have its own price. Whoops. And a product code. This is a blueprint. Here I say box A. We now have a box. Here I fill it with soap, $4.95, and I put in some make-believe product code. These are our members or fields: product, price, product code. And notice they're all inside one box called A. Recall when you had an array of 5 items, 1, 2, 3, 4, 5, I could just initialize it like this. And the array data would have these items, 1, 2, 3, 4, 5, placed inside. Notice the syntax: open, close, brace. First item, second item, third, fourth, and fifth item. Here we say we have a structure called a weather datum. Datum just means one piece of data. It has 3 variables inside it: temperature, wind velocity, barometric pressure. And notice there are helpful comments: Fahrenheit, miles per hour, and inches of mercury. Otherwise, nobody would know what units to use for temperature, wind, or barometric pressure. Next, I want to create a variable. I'm calling it ice station zebra. If you go back a few slides, quite a few, there's my ice station zebra there. That's where I'm getting it from. All right, let me go forward. So it's saying 72.5 degrees temperature Fahrenheit, wind velocity 4 miles an hour, and inches of mercury 29.92. And I can print out the wind velocity. I can say cout ice station zebra, go get the variable called wind velocity, and it will print it out. Here's another box. Again, I have the box for the product, the price of the product, and its product code. Box B, I called it B. B is a what? A box. It has rice, that's item 0, item 0. Item 1, I put 9.95 for the price, item 1. Item 2, 0027819110 is the product code for this next item. This is called initialization. Now we're going to go on to the world of data points. So we have a y1 and x1, y1, x2, y2, and maybe I'd like to calculate the distance between these 2 points. So I create a structure called point. There are 3 variables, x, y, and name. In my mind, the point looks like this, x, y, and name. It's an array. So I could say point A is 5, 5 alpha, 5, 5 alpha. The letter A by itself would point to the first element of this structure. Here I can have more than one, A and B, Bravo and Victor, at different positions. This syntax is from C++, 2017, which I will try to use often. Here I'm printing out box A, or point A, what's its name, and what's its X position, what's its Y position, with a nice comma in between. All right, here's point B. What name is it? It's going to be Victor. Its position is X and its position is Y. Notice X and Y, name and name, they're different. Why? Because they're inside different points. Now I'd like to have some sort of support function so I don't have to keep typing out this long string here. So a support function will be, give me a point. I don't know what point it is, but give me any point, a reference to a point, don't change it. So P is a reference to a point, don't change it, and the name is show. And it says whatever point you give me, show me its name. Whatever point you give me, show me its X. Then print out a comma, whatever point you give me, show me its Y position, and skip a line. So now I can see Bravo 5-7 and Victor 2-5. Doesn't print out very nice because I didn't put any spaces here, but we could fix that some other time. So what do I have now? I have these 2 points, and I'd like to know how far Victor and Bravo are from each other. I mean Alpha and Bravo, or Victor, whatever you call them. Well, I create another function. Whoops. I create another function called distance. Give it 2 points, point 1 and point 2. Give me the point 1, subtract the difference from point 2. The 2y is called delta y. Point 1's x minus point 2's y, call it delta x. And then I use the C math library. Ask it for the hypotenuse, and it will give me the square root of the sum of the squares, and I will get that distance. This is what I have so far. I have this creature up here called point, and I have 2 support functions, show and distance. Notice I call them APIs, Application Program Interface. These are interfaces. I really don't care how they work as long as I can use them to manipulate and think about points. Show me a point. Tell me the distance between 2 points. Once the internal gears work, I can just use the function API. Here's our main program. A and B, 2 points. Bravo and Victor. Show me Bravo. Show me Victor. Now I can say, hey, give me the distance between A and B. And we see what the distance is here. But what if I forgot to initialize Victor? Oops. I could get some really bizarre answers out there. I'm in a lot of trouble. But we have constructors and initialization to our rescue. We're not left there alone. We could actually put a constructor as a failsafe in point. Here it says, if you forget to build me, I'll automatically make x and y 0, and I'll give myself the name error. If you want, you can give me an x and a y and a name, and I'll take whatever name you give me, the x and the y, and I'll put them inside my x and y and name variable. So now I still did an oops, I forgot, but it made x and y 0, and it gave me an error. I wrote the word error there. My answer wasn't so bozo anymore, though. That could be safe. Here's another way of writing it. This is this modern syntax with a default. If you forget to give me ID, I'll make it error. And then if you forget to give me B, I'll make it 0. And if you forget to give me A, I'll make that one 0. This says whatever A is, put it in X. Whatever B is, put it in Y. Whatever ID is, put it in name. And notice the body of this function called point. Notice it matches the name of the structure. In the body, I put the word blank in there so people would know there was no mistake. I did this on purpose. And there's my X and Y. My structure point is becoming more sophisticated. So what do I have? I also have these two tools, distance and show. And they go together like a pile of junk. Why? Because they're not really related in a sense. It's sort of, I reach, I have this point. It's like having a nail floating around, and I say, oh, look, here's a hammer. Oh, look at this thing here. Here's a ball peen hammer. I get to choose what I want, rummaging through. This point, there's no way of displaying it. I have to go find this support function and know enough to use it correctly. If I want to find a distance between two different points, my point and another point, I have to know that this exists and use it correctly. So here's a way of organizing our thoughts. We have our structure, and then we have prototypes for our points. They go together like peanut butter and jelly. Notice in a prototype, I don't have to give you a name here because it doesn't matter what the name is. Distance, well, I don't have to tell you this is point A and this is point B, or this is point 1 and this is point 2. It doesn't matter what the names are. It's just 2 points. When I build it, though, in the gears that turn, these are the gears, I now have to give it a name. I'd say whatever you put here, call that point 1. Whatever you put here, call it point 2. And I use point 1 and point 2 here. Same up here, I only need 1 point, so I just call it P. Wouldn't it be great if we could fuse this all together? And yes, we can. We can make our blueprint the constructor, the show. Notice show no longer has a point in here, because when I say show, I mean show me. That is, show what my position is. If I'm a point, show my position. If I'm a point, I'll tell you the distance to the other guy. So I don't need P1 here. I am P1, X and Y. I know my own name and my own position. Nothing is built here. It is a blueprint. Now I need some more syntax. The scope resolution operator, the double colon. So I'll start down here at show. Here is show. Where does it go? This belongs inside point, and that's what that means. Put show inside point. The X is inside point, and the Y is inside point. Put distance inside point, because notice I didn't say P1 now. I just say X and Y. I don't need a P1. I just need to get the other point. Same here. This constructor belongs in point. There are gears. Now I have the main is basically our factory. We're actually going to build stuff here. Point A, 5, alpha, point F, 7, foxtrot. Show me A, show me F. What is the distance? A is, notice I said A dot show. I didn't have to put A in here. A is right here. And saying A is calling its own function show. That will show itself. F is calling its own function show. A has a function called distance in there. I say A says, how far am I away from foxtrot? And it will give me that distance. Very important thing with all this is our customer. We have to build different factories for different customers. Here's one, a video game where we have our hero, Hercules, takes on a monster. And we can show Hercules' position in our game, the monster's position. We can find out how far away our hero is to the monster. And if our hero is in range, notice I didn't use the number 3 here, I used a constant. If I'm less than in range, then the monster attacks our hero. We're using the same point, and now we just change the name of our variables. We now have a city center, the center of our city. We have an evil drone attacking us at this position. We have a laser cannon, spelled wrong. I guess it's lazy. Too close, if it's less than 5, I don't know, miles. Ask the drone, how far is the drone from the city center? If it's too close, fire a laser at the name of the drone and ask the laser, what is your range to the drone? See up here's the output of our program. Fire laser at evil drone range 2.23. We could use this type of thing, say airports. Planes take off and land. Where's the plane's position on the runway? Here's another example. We have a crop, and here's our structure, crop yield. This is modified from your textbook. I initialize the crop to empty. I don't have any crop in there. So when I do build this thing, when it's first built, if I don't put data in it, and if I forget, it's like a constructor, it will automatically be empty. If I first build this thing, this acts just like a constructor, and this is, I wouldn't use constructors with structs. I would just use this. Yield is set to 0. Notice I have comments to let people know what these things are. Now I have a farm. Farm number 1 has oranges, 20 tons. And I have a truck. I'm going to take farm 1 and put it in a truck. And I'm going to say truck is loaded with. Truck, show me your yield. How many tons do you have in the truck? And that will, of course, work. Now, instead of me writing this thing here all the time, I'm going to put a function in here, display. Display, loaded with yield. The variable right here, tons of crop, right there. Because display is inside crop yield. There it is. Oranges, 20 tons. I have a box truck. Copy to truck. And now display the truck. So that truck is loaded with 20 tons of oranges. However, if we looked at the farm and we displayed it, the farm still has crops of 20. That's ridiculous. The equal sign is an assignment statement. It just makes a copy. But we want to, in a sense, move the material from the farm to the truck. This is not powerful enough for us. So we're going to take advantage that we can pass functions, pass structures to functions. So I'm going to add another one called move. And I'm going to leave the variable name here called new owner. Transfer to new owner. What? Transfer the crop and the yield to the new owner. And I'm going to call it move. This is similar to move semantics. So I have inside crop yield, put the function move, tell me, notice it's not a constant, tell me what parameter. It's going to be a structure, and it's going to be the new owner. Whatever crop I have, give it to the new owner. Whatever my yield is, give it to the new owner. Then set my crop to empty and my yield to 0 because I have nothing left. I gave it to the new owner. It's my added feature. And notice it's passed by reference. So now what do I have? I have a bag of tools. I have my crop yield. I can display and I can transfer ownership. Run the code again just as before, except now I say farm 1, don't copy it, move it to the box truck. So farm 1 moves its material to the box truck. I displayed a box truck dot.display. It's loaded with 20 tons of oranges. Next, farm 1, tell me what you have. I am loaded with 0 tons of empty. There's nothing there. So notice I'm creating sort of a small language of move and display of fruits, vegetables, or anything else you can imagine. Here's a shortcut. I don't recommend it.